So one of the big problems in physics is when we have a sketch, we want to know how we build the free body diagram for that. So this video is going to introduce one way to do that. An interaction diagram is kind of an intermediate step to inform how the free body diagram comes about from our sketch. So how do we make an interaction diagram? Well, we start by drawing ovals for each object in the problem. So in this problem, we of course have our box, which we can kind of just write as the box. And then each object after that, we have string 2, which we can kind of just label as S2, string 1, label as S1. We have this left wall over here, so LW for left wall. We have this right wall over here, RW for right wall. And then something not shown in the sketch, but definitely in our problem, is the earth. So we want to write an oval for each of these objects in our problem. Our next step for this is we want to draw a box around the object of interest. What we're going to hear in next week and in future weeks is that this box is going to be called our system. So in this case, our box is going to have a little box around it, and everything is good with that. So our last major step is that we then draw lines for each force on the object in the system. So what we are saying is string 1 and the box are in contact with each other through a force of tension. So we can draw a line between string 1 and the box and label it with the tension. Between string 2 and the box, we can label another force of tension. We don't actually have any interaction between this left wall and the box. They're not in contact with each other. They don't have any non-contact forces. We could draw a line here, but it doesn't interact with our box, so we don't care about it. And lastly, the thing that we're, of course, not showing is that the box is feeling a force from Earth, so we want to label that as force of gravity. So as we were doing this, we want to label the type of force like we just did. So what do we get from this as we then do all of this? Well, what we get from this is that our object in the system is our recipient for the free body diagram. So then I can draw this. My box is what I'm going to be studying. And then what I can look at is each object, each line, going into the recipient is a force. Now, I do have to do things in addition to this. I do have to then figure out angles and things like that. But I can look at this, force of gravity from Earth, and that tells me that I have this force of gravity. I then have, this tension, and then I have this tension. And what I probably want to do is I probably want to label some angles, theta 1 and theta 2 for me, more so. And we have then this is a tension and a tension. But in addition to that, it tells me what the actor is for each of these forces. One of the big problems with free body diagrams is we oftentimes think there's forces that don't have an actor, and it turns out they're not forces. So this helps us confirm what the actor is for each forces. And this is also going to help us a lot next week when it turns out that actor-recipient pairs are going to be very interesting, And so the interaction diagram tells us the actor for each force. So something that's really helpful that we do if we draw free body diagrams is we want to write what the actor is for each force. So this is Earth, and then even nicer is if we can also write the recipient, in this case, the box. So this would be then 2 in the box, and this would be 1 in the box. And that helps us understand the difference between this tension 1